Okay, cool. All right, crew. So we finished GUIs last week, which I hope you guys thought were cool. I haven't had a chance to look at your assignments yet, but anybody have fun with that? Anyone sort of play around and do some fun like UI work with it, kind of accessorize their little ordering kiosks or what was the other one? It was the ordering kiosk, and I forget what the other one was, but the greeting app. Yeah. And you guys have some fun with that one? Not yet. Okay. Hmm. Have you guys gotten through the only fish green one? Okay, cool. Yeah, greeting one is obviously slightly less exciting and ambitious. Um, but as mentioned, we are moving on, and we have what I think is a really cool topic for us for the next 2 weeks. Where am I? This one? No. This one? Yeah, this is us. Module 5. We're going to be talking about networking. Um, this is I feel like GUIs is kind of where we started the journey of sort of bringing our programs to life in a way that maybe we haven't as developers been able to do up until this point. Networking is going to be the thing though that I think is going to really, really unlock just a ton of latent functionality. Um, for the simple reason, perfectly transparently, that the reality is most of the time these days, the software that you build, the software that you write, does not tend to house the data that it works with. Right? When we talk about full stack environments, it's this idea that you have typically, again, that sort of this backend data repository. Maybe it's like a SQL or a NoSQL, but some kind of database. And then you have software that sort of dynamically engages with it. And actually sort of taken to a little bit of an extreme, it can be argued that almost all software development, certainly all web application development these days, is basically just glorified CRUD apps. CRUD, if you guys aren't familiar, we're going to talk about this more next week. But that's create, read, update, delete. Those are sort of the four primary functions you can sort of do with data. And the reality is, virtually every web app, every interface that you interact with is just fundamentally a CRUD app. I mean, Messenger, Amazon, Google, I mean, you name it, they're all just kind of, yeah, just kind of CRUD wrappers. Um, so, so for that reason, you know, um, the data that you want your app to work with, for the most part, should not reside within the app itself. Right? It should exist somewhere out of that. And we've talked about that for a few reasons. The first one being, the permanence of it, right? Python storage exists in memory during an active session, right? The moment we're done, it kind of ceases to exist. And that's part of the reason why we sort of started talking about being able to write documents, right? Reading and writing documents, the ability to kind of store data in sort of a static, permanent manner outside of the confines of the program. But again, sort of beyond that, being able to kind of access data not only within your own system, but kind of across systems and remotely, is again something that really is going to make your apps come to life. And in fact, where we're going with this was something we already sort of hinted at last week. So remember last week we built a weather app, and I mentioned, right now we're just kind of using fake data, but in 2 weeks or now next week, we're actually going to sort of swap out those fixed variables and we're going to ping a remote API by the National Weather Service and actually grab real-time weather data to populate our app. Um, and it's kind of this just kind of cool idea that, right, we're used to this idea that like the data has to reside there. And no, really, it's about more so networking and communication and handoff of data than anything else. So that, by the way, speaking of, are you guys familiar with what APIs are? Do people know that term? Do you know the concept? Has anybody not heard of an API? No, we're all good. Okay. APIs, right? Application Programming Interfaces. It's basically kind of the way in which one program communicates with another. And that's really what we're going to talk about today in terms of networking sockets. So, yeah, okay, heard of it. Great. Okay, great, Una. Um, so we're going to be talking about that in terms of network sockets, client servers, communications, and then potentially sort of files and file transfers across networks. That's kind of what we've got lined up for us tonight. So, generally high level overview. Before we kind of get started, let's talk about what network sockets are. So essentially, these are, again, you can sort of think about these like APIs for your program. These are endpoints used for communication between two machines over a network. So these are essentially what allow programs to talk to one another, literally. And these can either be, as we'll see tonight, located on the same machine, or these can be located across a network, or even ultimately next week across the internet. And so, given how essential this sort of functionality is, unsurprisingly, this is sort of a core functionality of Python. Python comes with a pre-built module called socket, which allows us to create, configure, and use these sockets in your program. Okay, but why? And you might say, well, of course, why? We just sort of talked about, right? We were talking about APIs and getting weather forecasts and things like that. Like, what else is there to say about this? Well, we're actually not going to be thinking about it tonight in terms of web-based communication. That, again, is going to come next week. Although the interesting thing is it's built on the same technologies, which is another conversation. We're instead going to talk about um, programs within the same machine talking to each other, or within the same network talking to each other. And that then does beg the question of, but why? And the answer to that is a word called microservices. All right, now another pop quiz. Anybody here heard of microservices? Anybody familiar with that concept, that paradigm? Anybody want to hazard a guess? What do you think microservices are? All right, I'm gonna give it to you. Y'all got Andor on in the background, don't you? Just listen to that Gorman. Okay, let's spell this out for you. And this is kind of interesting. Let's go on a little walk again. Let's go on a little journey. So y'all are here, y'all are kind of, working at the system. You go through, you get your little certificate. Google comes knocking and be like, "Hey, we need you to come work for us." And you're like, "Sure, I'll come work for you guys. Sounds great." So you get hired. You're going to be a software developer for Google. Awesome work. Congrats. We're all proud. But you show up day one. Um, how do you get started? And here's kind of a funny thing. I don't know if you've ever thought about this, but how on earth, it's one thing when you're building code from scratch, right? You have this own little project, your own little thing you're kind of doing. It's another thing to jump in, midstream on a company, in particular a company like Google, and to talk about how it is that you can get anything done in that environment. And let's sort of talk about specifically what I mean by that, because there's really sort of two confounding issues there. And again, maybe this is something that's kind of bothered you, maybe it hasn't, but it's worth kind of pondering. So the first thing is let's talk about kind of understanding Google. Because, again, and I'm picking on Google, but Google is maybe a little bit of an extreme, but the reality is this is the nature of kind of any mature tech stack. So about a decade ago, Google was estimated to be 2 billion lines of source code large. Again, that was a decade ago. So, I mean, we're not talking, Gemini AI. We're not talking about a bunch of new services that they've rolled out, last thing. I mean, it was 2 billion lines of code a decade ago. Now, think about the scale of that. And think about, I mean, how long it would take. And literally, these are one of those systems where there is not a single human being alive who understands Google. It is just simply too big, too complex. You could spend your entire life studying Google, and it's doubtful you would ever understand the totality of it. And even if you did, even if you lived this monastic lifestyle, you copied the base source code, you went up to a monastery, you swore a life of was it not chastity, but a life of, well, a poverty and what am I trying to say? A life of simplicity, a life of, you swear off material possessions and you study the code for 70 years and you come down from the mountain. Well, meanwhile, has the code stayed the same? No, right? It's constantly in flux. It's constantly changing. It's constantly evolving. I mean, my God, like literally, I guarantee you, Google is probably pushing in, across the entire organization, they're probably pushing dozens, if not hundreds, of updates to their production code every day. And so, how on earth in that environment do you ever learn enough about Google to ever make a meaningful contribution to that, right? How do any of you ever become familiar enough with the code base to actually, again, be able to sort of meaningfully do it? And again, it's not just Google. You get hired by any production company. Again, even my own little Camaradia app is easily hundreds of thousands of lines of base code. I mean, I barely know it, and I've been there from the beginning, and it's hard enough for me to kind of get around it. Imagine someone else coming in. Any regular sized company will easily have millions of lines of code. How, again, right, is it's a matter of scale. And so that's kind of one, I think, challenge. But that's not the only challenge, because as I mentioned, right, you're not the only developer working there. Google has literally tens of thousands of software developers working for them across the world. And they're all working in parallel, working on different little code, different little things. And they're all kind of pushing updates. So how on earth do you ever coordinate that? It's hard enough to do it as a basic team. How do you do it on the scale of something like Google? It'd be impossible to track what everyone is doing, what every person is doing. And, how do you know that you are not inadvertently breaking something that some other team needs, right? Or, by fixing something, you've inadvertently broken a dependency that was essential to some other process. So, yeah, I mean, and let me ask you, is this something you guys have ever thought about that? Yeah. Well, and it's interesting. I will tell you, like, this is something, I was always fascinated by. No one really ever talked to me about it. Now, if you go into like a CS program, there are software development courses, and they do sort of talk about precisely these problems because, as you can see, at some point, it's not about just the raw code anymore. It's about coordination, right? It's about project management at scale. It's really about sort of how you do that. And oh, wait a second, didn't I say that sort of key word there, right? Scale. So remember, this has been, as you recall, one of these kind of recurring themes that we have been hitting week after week after week in this class, which is how do you scale up your coding, right? How do you sort of build code to scale? And and a key part of that is, we've talked about sort of modularity as being sort of a persistent and recurring theme in the way in which we code. And the notion being that there's sort of a fractal element to that, right? The first most basic element of this is functional coding, how we can sort of wrap self-contained sequences of code blocks into, on-demand executable blocks of code through functions. And then, of course, we talked about classes, right? And we talked about modules. So the idea of being able to sort of collect um, attributes, classes, functions in sort of self-contained files that basically serve as sort of libraries for one to another and do that, right? And so we've sort of been going again, sort of, if you think about it again, it's like a fractal, we've been pulling out and out and out and out. We're now going to take that one step further. And what I would argue, ultimately, we're going to take this to its ultimate logical extreme, which is simply this. When you code something to the scale of Google, you are no longer talking about one big app. Okay? There is no Google.exe out there. That just simply does not exist. What you are instead doing when you have to code to that scale is you're building a bunch of smaller, function-specific applications that are designed to operate completely independently of one another, but in turn communicating with each other as needed to create the broader application sort of experience. And again, this is any code at scale. This is exactly what happens. You work for any major tech company. This is kind of how this looks. And by the way, this paradigm in software development happens to be known as microservices, right? Which again, sort of intuitively makes sense. You don't have one big overall Google.exe. You have a bunch of self-contained, siloed mini apps that work together. So, okay, so this is kind of just a restatement of the definition. But again, the key thing to know here, each service here is completely self-contained. It is independently deployable. And it is focused on performing a very specific business function within the broader app. And so, this is sort of an example. I think this is kind of a take on like Uber, for instance. So you're going to see here you have an overall API gateway to external users. Within that, you have now an API that handles passenger management. So passenger management may be sort of a back end uh, thing for that. And then you have a passenger web UI, which is an entirely different framework that handles kind of a front end UI, right? And you have a driver web UI and again, a driver management. So you now have middleware for that. And overall trip management, which is a link between passengers and uh, drivers and so on and so forth. You have an entire payments module that again handles um, uh, disbursement of payments to drivers. You have billing, which again sort of bills passengers and things like that. You have push notifications, which are typically their own entire like stack and things like that. What you notice that you see here is like user authentication, account verification, things like that. These are oftentimes very typically their own um, sort of self-contained little things. And as you can see, right, each of these things is not in its own right a self-contained, is not in its own right a full app, right? Again, payments maybe takes in payment information, contacts third payment, or for billing, I should say. Billing, will take in user account information, we'll take in trip information, we'll submit that to a third payment processor, we'll process the payment, and then we'll, do that, right? It is kind of a self-contained functionality, but in itself, again, just like with a function where you have kind of a discrete set of inputs and returns for a function, it's the exact same thing here for this application, right? It can take in a very specific set of inputs, again, passenger information, trip information, things like that. It can take in that information that's needed. It can process the actual billing, actual sort of payment processing, and then um, we'll sort of return the result. And the idea is, and you'll notice here, there are a bunch of APIs within the app itself. Right? So both of these, again, completely self-contained stacks that then talk to each other via APIs. The same way we have an API to external customers, and we have to environments outside of our application. All of these little microservices are using APIs as well. So, okay. So let's kind of, again, begin to sort of, let's flesh this out a little bit more and begin to sort of think about how this works. So generally speaking, here are sort of the key conceptual elements of microservices. So again, the first thing we've sort of already touched on is decomposition, right? So again, a broader application, something like an Uber, a DoorDash, something like that, it's decomposed into small, manageable services, each of which sort of has a unique piece of functionality. Um, and this allows for, which leads to the other thing, independence. Each of these operates completely independently of the others. Typically, it'll have its own database and its own tech stack. And by the way, this is sort of an interesting point around this. Because they're completely siloed and completely independent, it allows teams, generally speaking, to code in programming languages, frameworks, databases that are most suitable for that particular business case. Um, and that serves sort of two purposes. One, it's function specific. So, there are certain um, processes that maybe one application, one coding language excels at, but another one doesn't, and vice versa, right? And this way, you don't have to make the choice over which one to go with. Moreover, oftentimes it could be team specific too. If you happen to have a team or, the people who kind of built it out initially happen to be really good at a particular language, they might just code it out in that too. This, by the way, is why, and this again, one of these other kind of questions, it's never easy to answer questions like what language is Google coded in, right? I don't know if you ever wonder this, but like, people are asking like, okay, well, what's Google encoded in? And people, don't really have an answer for that. And the reason is because it happens to be Google's actually encoded in a lot of languages, including Python, by the way, but not just Python. There are a number of, I mean, basically probably every major programming language shows up somewhere in some stack for one of the Google microservices. Um, and so, and again, depending on, so even if you are hired for a company, you might be hired and you might be encoding in Java, but your friend gets hired, same company, but might be working in Python. Or, you may be, transferred to another team and suddenly you are coding in a completely different language. Because again, it is stack dependent. So that's kind of another interesting note about microservices. Another thing, again, we've sort of already touched on, but we'll make it more explicit, is communication. So again, these, right, because they are completely self-contained, they essentially act as independent applications with their own well-defined APIs. And we'll talk a little bit more next week about sort of the specifics of this. But the interesting thing to note is that these APIs tend to use web technologies like HTTP, RESTful APIs, the kind of API technologies we use to communicate across the internet, just for the simple reason that one, they happen to be really robust and really well defined, and two, it just happens to be something everyone knows and is familiar with. So, it's kind of counterintuitive to think about that. But again, even within like Google, a bunch of little services are communicating with each other using HTTP and other, again, typically kind of what you would think of as like web technologies for it. Um, let's see. I'm going to talk about a little bit more with resilience, but sort of a key thing again to note here, right? Think about functions. Again, functions, you take in defined inputs, you have, sort of a black box of code, and then you have a very clear output. And an API is exactly the same thing, right? An API will say, feed us the following fields, the following information. We're going to do whatever we do internally, and then we're going to return whatever the result is to you, right? So, and this is sort of another thing um, that ties into the next thing of scalability. Because remember how I said, like, how do I keep track of what one developer team is doing versus another versus another? Well, the good news is I actually don't have to keep track of that much. Because really the only way in which I sort of communicate with them is these endpoints, these APIs. So, as long as we remain consistent in terms of what they expect us to hand over to them and what they in turn are handing over to us, it doesn't really matter what else they're doing. Um, it kind of is all um, the same. They can do whatever they want internally as long as those API endpoints remain consistent. So that again leads to scalability, right? And what is specifically a type of scalability that we call horizontal scalability. Because again, rather than having to worry about all these teams doing their own things, you can kind of focus on your own thing and just be like, oh yeah, again, let's say you're the billing people, you just like, yeah, account management, I just need these fields presented in this format to our API, and we'll take it from there. You can do whatever you want. I just need that, right? So it allows us to scale organizations horizontally and allows teams to focus in on their particular sort of things. By the way, this is sort of another interesting thing I'll note. This is another reason why when you talk to developers, and it's interesting, like if you talk to software developers, if they're just talking to like regular people, they'll be like, oh yeah, I work for Google. But if you talk like as within the industry, they'll never just say I work at Amazon or I work at Google. They'll specifically say like I work on Android, search for Android for Google, or I work for, two-factor authentication for X, right? Something like that. Because they're very team specific, because typically when they get hired, they're getting hired to work on one of these microservices. And again, because these stacks are so different, they don't really have visibility and they don't really have insight into what one of those other stacks are doing. Because it's really like they're not getting hired to Meta, they're getting hired to newsfeed, the newsfeed team at Meta, right? Which again, is it going to be its own microservice, its own little stack? And by the way, which also leads to the other point, right? Which is they don't need to learn the entire Meta Google stack. They just need to learn their one silo. And granted, right, that can be a challenge in its own right. But, again, typically I think they try to sort of factor and control that as well. But the idea being that, again, they're hired by a particular team to work on a particular functionality within it. So, um, another thing to know is resilience. So remember how, again, these are designed to sort of be independent. Well, part of that independence is they also learn because there's only sort of a handful of APIs that they have to worry about. They can try to build in workarounds to what happens if another thing goes down. So, for instance, what happens if billing fails? you know, and isn't able to send something back to trip management. Well, the trip management team can kind of write for that, right? You can think about a very easy try except that says, hey, if billing doesn't return the expected thing, how do we handle that? And so theoretically, right, if you've kind of built these properly, your own little microservice should be fairly robust to disruption from other microservices. Right? So if passenger web UI goes down, you on some of these other services should be able to handle that. Whatever those handoffs work on, because again, because it's a controlled inputs, because these are controlled entry points, you can sort of build in, again, try except blocks for what happens there and essentially try to sort of make your code robust enough to handle that. Which is why, although it does happen, it's very rare for major applications to fail, right? Again, it does happen, granted, but it is exceedingly rare. And even though they are continuously pushing code all the time, it rarely leads to this sort of major system outage that you probably would expect to happen. Um, Again, sort of continuous delivery. I will say this related to that. So each, because right, each service is independent, they're able to sort of push code again and largely not have to coordinate that, right? You don't have to work on like release schedules. You don't have to sort of do these things. Each individual team can kind of release on its own pace. And again, as so far as, disruption to other microservices are minimalized, it sort of allows you to kind of work on it the way you would. So that allows teams to push code and not be bottlenecked by other teams and other dependencies. So that's why you're constantly, right? These teams are constantly able to push updates to their respective stacks without worrying about how it impacts them. Then again, related to that, right? If you're constantly able to do that, you are also constantly able to evolve it. Because again, I can, if I want to rework passenger management, if I want to say, like, let's say I'm on a SQL database, but I want to move to a NoSQL solution, or I want to move to a Postgres solution, or I want to rebuild our backend in C versus, currently in Python or something like that, right? I can do it because, as long as I'm controlling these endpoints, I can sort of basically do what I want with fear of minimal disruption to it. So it allows your code to be flexible and allows your code to be evolutionary as a result. So I know there was a lot. Let me pause here and give you a second to digest, but more importantly, give you a second to ask any questions on that. Because again, hopefully this is sort of a brand new way of thinking about software that maybe we sort of haven't explored previously. Any questions? No, you feeling it? Not feeling it? No questions? Yeah. Cool. Does this hopefully help to sort of, I guess, kind of maybe answer some questions, maybe some things that you weren't even sort of thinking about or aware of when it came to software? I hope it is, because I know like when this clicked for me, it was like, wow, like this actually kind of really helps me think about sort of software at scale in a way that I hadn't previously. Cool. Well, I hope so. Because again, I found it really cool when I first learned about it. So hopefully you feel the same way. Yes, Munina, great point. Yes, so Munina had a point about style guides and why. So oftentimes companies will develop, internal style guides. It's interesting. Well, let me finish that point. But yeah, exactly right. Because right, so many teams are coding things independently of one another. That they're often right. There isn't necessarily a UI team. There is, you know, different services, different sort of things will have their own UI components. And yes, exactly right. You sort of need oftentimes to standardize um, um, you know, styles across sort of across, different sort of development teams. As an aside, is anybody familiar with Bootstrap? Has anyone heard of Bootstrap? Heard of it in passing. Okay, I got one person who's heard of it. Okay, so interesting enough. So Bootstrap actually started as style guides for Twitter. Interesting enough. Maybe not interesting enough. But so you'll so this is so if you go the web development route, right? If you end up taking like 192 with me or someone else, you're going to learn about Bootstrap because basically everybody uses Bootstrap. But essentially the idea is so basic kind of web architecture, right? You have HTMLs for your content. You use CSS um, for styling, JavaScript functionality. And so, yeah, so Bootstrap is basically kind of this plug and play. It's basically a style sheet for the internet. They kind of went through and they styled everything. Every component of a modern web page, they styled it and made it, really clean, really functional, um, responsive to different browser types, different sort of screen types. Like it's just fantastic. And the idea is, so the appeal of that is that rather than kind of having to build up your own style guide from scratch, you can basically just kind of import the Bootstrap style guide and then just kind of like apply it to your website. Basically say, oh, I want this button to be a Bootstrap blue button. I want this one to be a gray button. I want this to be a thing. And you just kind of run with it. But yeah, Bootstrap started as a style guide for Twitter. It was one of the teams. They did precisely that. They were like, hey, let's again, encode up the styles for all these elements because we have all these teams doing this. And then eventually they're like, hey, this is pretty cool. We should publish it, make it open source. And indeed they did. And that's kind of the way like a lot of open source happens. So that's another thing. I'm sorry, this is a little bit of a tangent. I wasn't thinking about talking open source, but so you guys are familiar with open source software, right? I mean, basically the entire industry kind of works on open source. Um, but the interesting thing is, so there's sort of a symbiotic relationship because everyone uses open source software. I mean, every like trillion-dollar company uses open source. I mean, just as an example, right? All those cloud computing servers, they're all Linux servers. Linux is open source, right? I mean, everything is open source. Um, uh, but the flip side of this is oftentimes a lot of companies um, will sort of will develop products internally and then particularly if they're not necessarily core business products, but they have a lot of utility, they they will open source them. And so Bootstrap is an example of that. For instance, machine learning, Google open sourced like TensorFlow, PyTorch from Facebook, things like that. Like all of these frameworks were open sourced by the thing. And so you might ask, like, why would they do that? Like Bootstrap is really useful. Why would Twitter potentially do that? Aren't you like empowering your adversaries by open sourcing stuff? Um, I don't know if that's a particular area that you've spent any time thinking about, but does anybody kind of know why companies do open source things? Like, what is, I mean, because let's face it, big tech is not known for its um, whatever. It's not known particularly for its charitable works and kindness and yeah, benevolence. So anybody know why? Anybody have any? That's why, like, why did Twitter decide to release Bootstrap as open source? I'm not sure. Right? It's kind of somewhat counterintuitive, right? So there's an interesting sort of thought here. So it's sort of a twofold thing. So firstly, by making it open source, it other teams and other people sort of contributed to it. So, you're using it for your business, right? You're using it already for your own business. And, you're obviously paying developers to do it, but there's so much that they can do. By making it open source, suddenly you get a whole bunch of free contributions to your little platform, right? So Bootstrap is infinitely better than when it was just Twitter's Bootstrap because you have literally an entire sort of global community contributing to it. So that's number one. So one, it makes your own tech stack stronger because again, you get people contributing to it and improving upon it. But then number two, it also kind of works as a recruiting tool because you get people working on the tech that you're using internally. They get good at that tech. And then when you turn around and you want to hire them, they already know how to work with your tech. Oh, a great example of this, actually, maybe the best example of this is React. So I don't know if you're familiar with the JavaScript framework React, but basically the entire web application architecture works on that. Well, that was developed by Facebook and then was spun off, open sourced. And again, right, same basic idea there. Yes, theoretically, some rivals to Facebook, um, were able to sort of use React to maybe sort of make competitors with it. But in turn, Google now has an entire army of developers out there working with React. And, whenever they want to hire, well, now it's trivial to onboard people because you have an entire ecosystem of developers out there using your technology, working with your technology, and familiar with it. So ultimately, believe me, these companies are not doing it out of the benefit, of mankind. For them, they recognize the value in kind of opening it up to the community and cultivating the community for that. So that's the whole kind of trade-off, if you will, between open source and whatnot. It's a very similar model to the freemium model, right? That you see with like a lot of businesses. Oftentimes, they will get, particularly individual users, they'll offer sort of a service free for individual users, but then sort of make it cost for enterprise, right? It's sort of a similar idea. It's the idea you get people using your platform, you get people comfortable with it, and then ultimately, once they're using it and then want to continue to use it, maybe, particularly at the enterprise level, they'll pay to do it, right? So same basic, it's not the same strategy, but it's a very similar strategy, right? It's a similar, you kind of you give something ultimately to get something. So that's the world of open source software. Boy, Munina, what did that's what you get for talking about style guides. So there you go. Um, let me let me finish. Okay, so now the whole thing was on microservices. How do we enable microservices? Networking, right? So once you have these standalone applications that need to communicate with each other, they do this using these sockets, using sort of networking functionality. And one other thing we'll sort of see and talk about, and this is going to be kind of like, I know I've been sort of lecturing at you for a while. We will take a break after this. But this also, so networking also fundamentally works in a standby mode or an event-driven sort of mode. So remember, right, with GUIs, we sort of introduced that paradigm. We said this is a very different way of our code running, right? Typically, classically, we would have code. It would sort of, when we hit the Python myapp.py, it would sort of execute the code and run start to finish. That was sort of the way in which it sort of propagated and worked and blah, blah. With event-driven programming, it would sort of launch, but it would go into standby mode, right? It would be passive. It would be listening. It would be reactive and responsive. It would sort of enable a user to sort of engage with it. And then when did, it would sort of respond or react to it in turn. So networking is going to work exactly the same way, right? As you're going to see kind of again when we walk through it and kind of when we come back from the break and kind of walk through it, when a server launches, the first thing it does is it listens, right? It's not immediately kind of flooding the ether with all of its sort of thing. It's just sitting there. It's in standby mode. It's listening for requests to come in. And then requests will come in and you'll sort of facilitate that exchange, that communication, typically between client and host or client and server. So again, so we introduced the idea of event-driven programming. in the last module, we are going to continue it and extend it and expand it here as well. So, all right, so that in a nutshell, microservices, networking, why we want to use it, why it is so useful. Um, yeah, any questions? All right, so you guys earned an awesome. You earned a break. When we get back, we're going to sort of walk through the process of how you create, initialize these sockets, and we're actually going to kind of walk through and ultimately build a basic sort of client server uh, parallel set of applications that we're going to run together. So, because as you'll see, it's actually right like many things in Python. Uh, it's really, really simple to actually implement this. You import the library, you initialize the particular object of those particular classes, and then you kind of just run it, right? It's um, very user friendly. You spend more time talking the theory than actual code. But all right, should we convene? Let's reconvene. Let's say 7:35. Give you guys a nice little break. Me too, to be honest. All right. Thanks, crew. I'll see you guys shortly. Resume. Let's get this going. Okay, so let's actually walk through. So what we're gonna do is I'm gonna sort of talk through the basic kind of logic of kind of setting up and launching your sockets. And again, then we'll run through a really, really basic example of it. So, all right. So again, sockets. So first thing you gotta do is you've got to create the socket object. Da, da, da. So the first thing you know is you're going to import the socket library. Again, it's a base library, so you don't need to do an install. You just need to import it into your project. Then you sort of create the individual thing by invoking from the socket library the socket class, right? So you're going to create a socket object. Now, this takes in two parameters. It takes in your socket family and socket type. So socket family specifies your addressing mechanism. Are you using IPv4 or are you using IPv6? Just out of curiosity, does anybody know what IP addresses are and sort of that whole thing? Because we're going to talk about it next week, but I'm just kind of curious if you guys are familiar with that mechanism. But so again, like I mentioned, right, this is sort of it's essentially the real basics of it is it's the addressing system for the internet. Um, and so yeah, so we use basically the same kind of internet addressing system regardless of if we're using our again, if we're just kind of communicating internally on our own device, our own network, or again, sort of remotely. So we need to do socket family again, IPv4, IPv6 to be discussed next week, but just know that that's your socket family and then socket type. And that basically talks about what your transmission protocol is going to be. So the mechanism of information exchange. And again, these are also web technologies. Specifically, are you going to use TCP or UDP, which is the two primary transmission layer protocols for sending information across the internet. So you would say sock stream if it's TCP or sock dgram if it's UDP. So as an example, you'll see here, we're going to initialize a little socket object and we're going to set socket.afinet, which is going to be IPv4, right? It's an attribute of the socket library. So it's going to be IPv4 and sockstream, which is going to be the TCP protocol for it. Okay, so you then create it. The next thing you need to do is you need to bind it. So you've created that object. You then again input you then sort of assign very specific things, and specifically you uh, define the host address, and then which can either be localhost or you may be familiar. You could do localhost. You could do 127.0.0 point 1, which is again the local host address. Just means that you're basically bouncing it back to your own device. Um, and then the port. So your IP address is sort of the address assigned to your overall computer. The port is the specific, if you want to think about it, it's kind of like the specific parking space, if you will, assigned to it. So, at a particular address, you could have multiple applications. These applications receive communication sort of at different sort of things. You might think about it like mailboxes or something like that. Yeah, mailbox is a good example of this, actually. Actually, I like that. I'm going to go further. I'm going to say it's like a PO box, okay? So, like, the IP address is basically the address of the post office. It's saying, hey, deliver the mail here. Your port is the PO box. It's the specific, um, again, sort of the specific parking spot that your application is listening to for communication. Again, that's what potentially enables multiple applications to run on multiple different ports simultaneously. So you then bind that. So you pass in, so that's a tuple that you then bind. You use the bind method to then again assign or bind that particular addressing system to your little server. And by the way, sorry, I should mention, right, generally speaking, when we think about networking, there's a little bit of an asymmetry. And which isn't to say that both sides don't necessarily there can't be an exchange, there can't be a bidirectional exchange of information. In fact, what we often find is exactly that um, both sides can sort of send and receive information. But generally speaking, when we think about networking, we have one side that is the host slash server, and generally that is the event driven side of it. So in other words, it will you'll launch it and then it'll kind of just sit there and it'll wait for something to happen. It will literally be listening. Um, and so that's going to be the server side, or the host side. And then the other side of it's the client side. The client side is the one that actually initiates the exchange, the conversation. It's the one that pings the server that initiates the conversation. Now, again, once the conversation is open, it can be a bidirectional exchange of information. The server can send information and receive it. The client can send and receive information. But the idea is at least to initiate it, right? And if you think about it, that kind of makes sense logically, right? If both sides are passively listening, nobody's ever going to communicate. If both sides are trying to like ping each other, right, they're just going to kind of keep missing, right? So you kind of have to have one side initializing the conversation, the other side kind of being receptive to it. So that's how we think about this. So anyway, okay, so binding. So we've now bound our little socket to that particular address. And then for our little server, the next thing we would sort of initialize, we say the listen thing. And again, listen is what launches the server and gets it up into event driven mode. So it goes live, it goes to that port and starts listening for connections. And you might see here, you can actually specify the number of queued connections in it. So generally speaking, if multiple sort of clients are pinging at the same time, engage things sort of how many connections is it willing to sort of hold in its queue. And this, by the way, is a very big issue with sort of networking traffic, is because oftentimes like congestion can become an issue, and if there's too many requests, you may drop and things like that. And in fact, you might be familiar with like one version of hacking is a DOS hacking. Have you guys heard of DOS hacking? Denial of service? Anybody heard of that style of hacking? I got one yes. Munina, you want to take a gander at what DOS or a DDoS is? A distributed denial of service. So I won't put you on the spot. Is it one of the overall? Yes, Munina, that is exactly what it is. Oh, you perfect. You said it concisely and perfectly. Yes, it's exactly what it is. It's you basically you do this. You overwhelm the server with requests, with pings. Yeah. And so as a result, it overloads their queues and their buffers, and they end up dropping connections. So anyone else who tries to sort of connect to it can't. So yeah, that is a denial of service. And then its related attack, the distributed denial of service, is when you get like botnets, which are pinging it from IP addresses kind of across the world. um, are are uh, are sort of trying to do that. So, um, yeah. So so again, so that's kind of what the listen thing is, and yeah, kind of a cool thing how it ties into hacking. You can theoretically, by the way, make a little hack bot here, right? You just need kind of a client if you know the website you're trying to hack, right? You can literally just create a client, just try to sort of ping them, keep pinging them until you overwhelm their server, and then, you know, at some point you can sort of, again, right, prevent anyone else from logging in. And it's interesting to know, right, doing those DOS things, the actual website itself isn't offline. Well, it can go offline because actually you can overload the buffer, you can cause a Stack Overflow, and you can actually crash their server. But there's versions of this that where the website's actually fine. It's just it's getting so many pages. There's just too much traffic that legitimate traffic gets boxed out. So yeah, a little bit of a interesting aside with that. Okay, so now what happens, so like in your logic flow, so now you've created your socket, you've sort of assigned its address and you've bind it to a thing, you've ordered it to start listening. Now you need to make the logic for what happens when it sort of receives a connection. So the way we sort of handle that on the server side is we have the accept method. So if it receives if it receives a request, it can then accept it. And then when it does, it then sort of stores the client address in the client socket, right? And that's kind of what allows us to then potentially communicate with the client. Um, so, and so that's going to be on the server side. And we're going to sort of see what the server does once it's sort of accepted and opened that particular connection. Um, but we're gonna now quickly, and you know what? Let me think. Should I just, let's just type that up. I kind of ran through that, so let's just kind of do it, right? Really quickly. So for this one, so you'll want to open up a code editor and then let me, new file. I'm gonna call this one. I'm gonna call this, um, 112 server.py. Okay. So again, to your first thing here, so give you guys a moment to get caught up, but before we do anything else, right, we're going to import socket. So give you guys a second to get caught up here. Now, you may remember, right, I'm just going to call this server equals, and from socket dot socket. Remember, it takes in those two parameters, your socket family and your socket type. So you may remember the socket family is going to be socket dot AF. Yep, inet. So it's going to be IPv4 and then socket dot. And then we're going to do sock stream. And it's going to be a TCP protocol for this. I mean, we know this right from the convention, right? Remember constants are uppercase. And so remember, it's a constant because this is an attribute that's stored in that socket library. So it's just, so it's just a variable that's stored there, but because it's in that other library, it's theoretically inaccessible for us. So we treat it like a constant. Okay, so we do that. Then we are going to bind it. So I'm going to say server dot bind. And so IP address, so again, you could do the 127.0.0.1, or you could just do local host. And then your port. So in this case, I'm just going to do, oh no, that's a number. Sorry, it's not a string. So I'm just going to do 1, 2, 3, 4, 5. And oh, sorry. And this has to be a tuple. So it doesn't take in two inputs. It takes in a single input, but that single input is a tuple. Okay, so it does that. And then server listen. And I'm not going to specify a queue because we don't really need it, but you could do it. And then I am going to do a little print statement. So once this goes live, I'm going to print to console. Server is live and listening on port 1345. Okay. And so then remember, we have to do something when it accepts it. I'm then going to do server dot accept. Oh, sorry. I need to specify the two things. So I'm going to say client and I'm going to say C address is equal to server dot accept. And so once that thing is established, I'm then going to print an update to my server saying print connection from, here, let me make this formatted string here just so we can sort of see this from C address. Received. Or actually, I say opened. Okay. So, all right, so now we're just going to do this. And in fact, we can kind of run this right now, and I'll show you what happens if we run it. So let me open terminal here. So I'll do cd documents, and then I'll do Python, and then CIS112 server.py. You'll notice here, it says server is live and listening on port 12345. Okay, so our server is live. It's not really doing anything, but it's at least live. I'm just going to leave that there. I'm not going to kind of touch that for the moment. Let's now take a look at the next side of it. So let's look at the client. Okay. So for the client, so client is a somewhat simpler thing. So in this case, so client is still going to sort of start largely the same. So you're still going to create your little socket. You're still going to set it to be IPv4 to using TCP. You're still going to do that, but you are then going to do you're then going to sort of do connect. And the connect thing is going to basically ping your thing. And you may notice here, we can either, right, you pass in basically a tuple with IP address and port. And so you're going to do that, and then you're going to be connected. So let's just do that, right? Easy, breezy, simple enough. We're not really doing anything yet, but we're going to at least create it. So let's create another file. New file. I'm going to save this as CIS112 client.py. And yep, that's going to go in documents. Perfect. All right. So again, same basic idea, import socket. And then I'm going to call this one client equals socket dot socket. And again, right, the two inputs, it's going to be socket dot AV inet and socket dot sock stream. Yep, perfect. Okay, so I'm going to create both of those. And now that I have that there, I'm just going to do a connect. So client dot connect, and I'm going to pass in my little address thing. So I could, so I'm just going to say here in this case, I'm just going to localhost and port 12345. Now, just to show that I've done it, I'm going to say print connected to host at. All right. So I'm going to do, so I'm just going to kind of set that up now, and I'm going to just run that. So again, remember our server is still live. It's still there. So so now I need to create actually a new terminal window. So see here, if I go to terminal, I'm going to create a brand new window. I'm going to stack it right here. I'm going to do cd document. I'm going to do Python CIS112 client.py. All right. Now you'll see here. So connection from, again, that's localhost 127.1.1, and then happens to be port 54221 was opened. You might see this, and it connected. And then stopped. Both of these halted because we actually didn't say what to do with it once we created it. So that's actually going to be what we do next. But so you can see here, we actually sort of initiated that little handshake there. So kind of cool, I think. Let me pause here. Questions so far? All right, so we're good? No questions? All right, let's keep chugging along then. So remember, the whole point of this, though, is information exchange, right? It's kind of, the fact that we just kind of communicated really didn't do anything to us. We actually kind of want to do something with it. So let's take a look at how we actually send and receive. And by the way, this kind of works on both sides of it. Both, again, because remember, once the conversation is established, once that connection is established, both host and client can basically sort of talk with each other kind of at will. So we can define the method, and we do it with sort of just two mechanisms to do this: the send and the RSCV, which obviously is short for receive. So the send method is used to send data over the connected. It just takes in a single argument, which happens to be what data is being sent. And by the way, typically this is in the form of byte-like objects. You might notice how there's a little B format there. So that actually is formatting it in terms of bits. You don't always kind of have to do that, but it's usually best to do it. So you're serializing it, converting it to bit code before then transmitting it. So yeah, so you'll notice here I define the data here, and then I just do a byte sent object, which is client socket send data. And that's what it's actually going to sort of send your data over to there. Now, the flip side is the receive method. So the receive method is used to receive data. So if data comes in from the socket, it'll take an optional argument that may specify the maximum size of the information it's going to receive. So you're going to see here 1024, right? So it's going to receive essentially 1 kilobyte of data from this. So that's sort of a maximum thing. If no argument is provided, it'll be default size. It then returns a bytes object containing that data, and then will sort of allow you to kind of parse that and just sort of display text. So using that, we can then sort of create our little conversation there. So let us say, let's do connecting the host. So let's first do this on the client side. We can, it doesn't really matter, right? We can sort of do this in any order we want to do, but let's just say I'm going to send. Um, so, so client send. In this case, it's going to be, well, I could just do, I guess I could do a code, or I could just do it as a bit thing. So let me see. I'll say message. No. So I'm going to show you two ways to do it. So I showed you the B method, but I'm also going to do it. I can also do it using encode, which will convert the string into bit thing. So I'm going to say, hello, server. Uh, oh. Right. So I'm going to encode this and I'm going to send this. And then I'm going to receive something. So I'm going to say received equals, and then it will be client.recv. And again, I'm just going to use the default. I don't need to specify that. And then I'm going to print server responded. And then actually I'm going to format this. received. And then I'm going to client send. Thank you. Good. Code. And then, should I do another one? No, I don't need to do more than that. So now, then, an important thing to note here, last sort of step in this process, is when we're done, we're going to close the socket. So we're going to close the connection. So remember, this is a conversation that you're having with the thing. So while you're actively having the conversation, you notice it's kind of like a back and forth. The server is holding that connection open. And so we need to explicitly close it now. So we're going to say client close. So client is going to close the connection on its end. So that'll be on that side. So now, so let's kind of do something similar here. We're this one. All right, so we receive it, connection from here opened. So now I'm going to say server send. I'm going to say hello, client. Thanks for joining us. The weather today is delightful. All right, and then we're going to encode that and send that. And then I'm going to need to do so first we need to receive something because, right, we can do received equals IECV. I'm going to print. So we're going to see that. We're going to send that back. And then I keep this again, but this I'm going to say client responded with received. Okay, so now we're going to capture that back and forth. Now for the server, there's actually sort of two things I'm going to do with this. The first thing I'm going to do is I'm going to close the individual client. So you'll notice here how we opened this thing here, this initial thing. So I'm going to now close this particular connection. But theoretically, I can keep the server running. So if I just do this right here, if I just do this, the server will keep running. It'll close the connection, but it'll sort of keep running. What I'm also going to do, though, is I'm also going to say server close. So essentially, I'm going to close the individual connection with the client, but I'm also then going to close the overall server, right? I don't want to kind of keep hogging the server. Once I've kind of done this demo, I'm good to go. So I'm going to close that thing. But again, worth noting that there's sort of two steps here. Close the particular connection, but then also when you're ready to close it, you close the overall server. All right, should we see this in action? Let's bring back our little things here. So let's run server. So you can see your server is live and listening on port 12345. All right, then we're going to do client. Oh no, what did I do? Takes one. Oh, really? So it needs a default. Okay, fine, fair enough. All right. So I thought that was optional. Apparently it's not, guys. All right, server, client 1024. Okay, let's start that again. Server is listening. Am I listening? Okay. So, ooh, what's going on here? Something's happening here. Okay, well, I thought this was, well, okay, so client, okay, good. So so connection was opened. Client asks, hello, server, how was the weather today? So far, so good. And then what happened here? Socket is not connected. Server responded B. Did my server disconnect? Is there a problem with my logic? It seems like is my client closing it before? Let me see. Okay, so I'm printing connection, right? I'm hello client. I'm receiving it. Yeah, I'm sending it. Oh, I didn't send. Ah, I know. Okay, I missed the whole thing, didn't I? Okay, wait a second. So server hello client, and then it receives it, and then I print the received, and then oh, I didn't send the response, did I? Okay, well, no wonder. Oh wait, no. I did do that, didn't I? Did I run the right thing just now? Let me see. Okay, sorry. Giving you guys a moment. Okay, so where did hello client, thanks for joining us the weather day. Okay. So this is tripping the error here. The second send, this first send. Server responded B. Hmm. Okay. So, right, connected to server. It receives that, decodes it. Oh, I see. Okay. Sorry. It needs to, because the order actually, okay. So this is, so it was waiting to receive it and it didn't receive anything yet. So actually we need to reverse this. So wait a second. Oh, I have too many. Okay, I was looking at the wrong one. So let me, sorry. Save. Okay. Okay, sorry. This was the right one. Okay. Server is listening, right? So first received connection from. So the server's first receiving it. So client sends first, where server receives, the server sends back, receives a response. Okay, so client sends, receives, prints the receives, sends, and then closes. That should have worked. Connection opened. It receives it. Client asks. Hmm. All right. Sorry. Let me run this again. Okay. Listening. Okay. So server is not responding. Okay, so this part worked here. Hello, server. How is the weather today? And then, okay, so I'm not entirely certain why. I'm going to be honest with you guys. I apologize. I'm not sure why this is erroring out for me. But somehow when we're trying to get the server to send the response back, it's saying that the socket is not connected. So we are not, let me see here. So client doesn't close until it receives it, and server doesn't close. Hmm. I'm going to test a couple things, guys. I mean, the basics of this, hopefully you're sort of seeing here working. I'm not entirely sure why this isn't working for me. I wonder if, oh no, that wouldn't have closed that. Anyway, I'm sorry, guys. I'm gonna have to check to see. look into exactly why this isn't working, but let me just comment out the close connection things. What if I don't explicitly close it? Same thing with you. What if I don't close you? If I'll let you guys run. Ooh, right. Launch the server. Yeah, so we're still socket is not connected. So why is I don't know if this is my I'm just kind of curious. Is anyone else encountering this issue? Because I'm wondering if it's my device too. If it's closing the socket. Same issue. Okay. So then there's something wrong with me. When I encode this up, I did something wrong. Because I should be able to send this. Yeah, let me just quickly. Let's see. Raise a new socket connection. So that's the object you should use for sending or receiving data connection. Before you call accept. Send all. So oh, it should be connection, maybe. Oh, maybe that's a typo. Hang on. Let me look at what I'm doing for my server here. Oh, maybe it's client. Maybe that's the problem. Ooh, that would be subtle if that's the issue. Okay, let me see here. So, client. Okay, I think that worked. Okay, cool. Okay, now it worked. All right, sorry. So let me tell you what happened here. Very tricky, but in this particular thing here, remember how I said I originally had this as server.send because the server is sending it? But what Stack Overflow was telling me is that no, you have to send it to the particular connection, not the overall server. So that's why it was giving me the error because it was saying like you don't have a connection. Because we did have the connection, but you have to send it that particular connection. So it has to be a client.send for that. Okay, so now let's look at the exchange because now it's working. Yay. Okay, so now you can sort of see here, server is live and listening, connection from, right, our little thing is opened. Client asks, hello server, how's the weather today? Um, Client responded, thank you, goodbye. And in this end, you can sort of see here, connected to host at port 12345. Server responded, hello, client. Thanks for joining us. The weather today is delightful. So, okay, cool. Fantastic. We got that working. Look at that. All right. So, okay. So that was the issue. Um, Anybody got any questions on this? Oh, yeah. Okay. I got a request to see the client file again and the server file again. Okay. So let me do client first. Okay. So here's the client one. All right. Let me know. And let me know if you need help debugging your thing, Una. And Klaus, I'll pull up server again in a second. All right. Una, did that help? Oh, and actually, sorry, I can uncomment out the close now because now it works the way it should. But so Una, you good on the client side? Okay, perfect. Klaus, hopping over to the server. Let me know if you have a specific question. Klaus, how you doing with that? Were you able to get yours working? Okay, sure, no worries. All right, while we're waiting, anybody else got any questions? Okay, you're good. Awesome. Cool. Okay. So I'll quickly mention, and we'll talk maybe about this a little bit more starting next week, but I just kind of want to mention, right? So we've already sort of talked about um, sort of how we encoded and serialized stuff. But you may remember, right, in previous conversations, we've talked about serializing data, and not just individual strings, but things like JSON files and XML files and things like that. And so the thing I want to end with um, is this idea that we can actually sort of, as part of the sending and receiving. Hi, bud. I'm just wrapping up, buddy. Do you think I could put you to bed, little cutie? Yes. Okay, great, honey. Do you want to say hi to everybody? Okay. Hey guys, my little teaching assistant wanted to come and wish everybody a good night. Savannah, you want to wish everybody good night? Yes, good night. Mhm. Good night, everybody. Good night. They're all wishing you good night in the chat. Buddy, can you give that a couple more minutes? And then I'll be down to wish you good night. How many more? 5 minutes. Uh, Okay. Thank you, buddy. All right. So, yeah, and we'll talk about this a little bit more, maybe at the start of the next class. But so you're going to sort of notice here, right? We have the ability, you're going to see here, like I can read in, for instance, a JSON file. So like if you look at this example here, heck, I'm just going to talk about it. It's simple enough for me to do. Um, uh, so you can sort of see here, right? So an example of how you can send a data file using the sort of pipeline we just kind of looked at. So server side, so as an example here, you can see sort of the server will create a read-in data from a JSON format. When a client request is received, then the server can process that data, serialize it into JSON format, and then send it over to the client using the network connection. The client can receive the data, it deserializes it into Python objects, and then can kind of use the data how it's needed. And so again, you can sort of see here, right, the server side, um, will sort of read in data it receives, it'll load the data, it will then serialize the data, right? Into sort of a serialized JSON format, and then it will send that, right? It'll encode it down to byte connection and send that data. Then when the client receives the data and then decodes it, it will then do the JSON loads. And that will convert it into, again, Python data structures. So, not just sending strings, but you can send entire, right, documents, data files using this network connection. So kind of a cool way of sort of running with it and extending it. Um, so yeah, so that's networking in a nutshell. Any questions on that? Let me see. Oh, okay. Oh yes, Manina, great. Thank you. Have a great weekend. And I'll see you next week. Okay, I have to log in. Boo. Okay. Now I will mention to you one thing for this week. So there's only actually going to be one lab for this module. And I'll talk about it really quickly this week, but we'll talk about it again next week. But the idea here is that rather than giving you two modules, you're going to actually just have kind of one big module, one big program, because as you might imagine, there's going to be two parts to it. There's going to be a server and a client. So you'll see here, there's kind of a lot going on here. I don't necessarily expect you to finish it. This week. In fact, again, this is the idea being this is a bigger program that's designed to take you at least sort of, the 2 weeks to work on it. So, but I'll at least introduce it tonight. And I think that'll be all I've got for tonight for us to cover. So, all right. Developing a client-server application in Python using sockets. So your task is to develop a client-server application using sockets. The application is going to consist of two parts. It's going to consist of a server, right, the host application, and the client application. Just like you've sort of already seen, the server is going to store information about individuals in a dictionary and will respond to the client requests by sending information about the requested individual if available. So the client is going to prompt the user uh, to enter. So the client is going to prompt a user to enter the name of individual they're interested in, is going to send the request to the server, receive a response, and display it to the user. Okay, so you're going to develop two things. So the client is going to take in an input from the, let's see here. Um, yeah, so let's talk about the client request first. So the client is going to take in an input from the user of a name of a person, right? That it will then submit that name as part of, it'll establish a connection with the server. It will then submit that name as a request, right? It'll send that request. You will have a server application that's obviously going to listen. It's going to have a dictionary of people where the people's names are going to be keys, and there's going to be associated information about them as values. And again, you can choose what information you want to include. Just have fun with it. So while the server is active, it should sort of have, again, it should send some updates, things like that. When it receives a client request, the server should then, should package the request, and then it should check to see if that name is in the dictionary, right? So if the client says, "Hey, I want information about Klaus," right, or I want information about Una, it should check to see if it's in the dictionary. If it is, you should sort of send that information. If it doesn't exist, the server should send a notification to the client that the person does not exist. Okay, so you can sort of use the pickle method to sort of dump and serialize and deserialize the data for communication for that. But yeah, that's kind of what we're looking to do for that. So that's, oh, sorry. So that's the server side. Again, for the client side, when launching the client, it should first prompt the user, enter the name of the individual. It should then send that to the thing, and then it should receive the response. So, and like I said, I will review this again next week. Again, I don't expect you to complete that. This is going to be the only assignment for this module. So, again, I released it this week. If you want to, you can start working on it. But the idea is this is supposed to take you a little bit of time. So, all right, guys, any questions on what you're being asked to do? And again, not too much, I think, of a stretch beyond what we already sort of saw this week. Right? Really, the only difference is now a few differences, right? You're taking an input from a user on the client side and bundling that into the request that you're sending. And then rather than just sending a static message back, your server is going to receive the request, basically kind of conduct a data search and then return the results. So. Yes, I hope you like it. I think it's kind of it's like a little bit of like a little mini search engine that you're going to be kind of doing for this one. So hope you like it. All right, crew, that's what I have on my end. Any other questions? All right, on that note, I'm going to end the recording. Everyone have a great evening.